Alhamdulillah, wassalatu wassalamu ala rasulillah. Muhammad, assalamu alaikum wa rahmatullahi wa barakatuh. On behalf of Gamji Educational and Mentorship Forum, I, Buharilo Muhammad, I welcome you all on our today's workshop on with the title Conducting a Meta-Analysis Using a Comprehensive Meta-Analysis Software. So this workshop is organized by Gamji Educational and Mentorship Forum and is going to be presented by our Abul Dr. Muhammad Chutiyami, who is a lecturer at the School of Nursing and Midwifery, University of Technology, Sydney, Australia. So as the title turns out, we are going to conduct a live workshop on how to conduct a meta-analysis. As you all know, since you join, I believe you are interested in the conducting meta-analysis. And meta-analysis statistical technique used in research in order to combine and analyze the result from multiple studies on a particular topic so that to draw a generalized conclusion. And the techniques is used in various fields such as healthcare and medical field, economics, biological science, environmental science, and many more. And I believe today we are in a very good hand. Our presenter today is expert in public health and infectious diseases. He has published several articles on biomedical topics, in some of which he published a lot of articles on systematic review and meta-analysis in reputable journals. So I believe we are going to learn a lot from our Abul Doctor, and as shows in the instruction, it will be good if you can join with your personal computer so that it can be a practical session or is going to be a hands-on learning. But in case you cannot be able to join with that, the workshop is already being recorded, so later we are going to publish in our YouTube channel so you can access it and follow it afterwards. So thank you very much once again for joining us. I will hand over to our Abul Dr. Muhammad Chutiyami. Thank you very much, and the floor is yours.
Thank you, Buhari, and thank you everyone for coming to today's workshop on conducting meta-analysis. So if you permit me, I would love to share a slide. Yeah, I think I should be able to. Good to go. So hello everyone once again. Thank you for coming to this workshop on conducting meta-analysis. Obviously, as you can see on the screen, is going to be kind of introduction to tell you the basics of what it takes to conduct a meta-analysis. And I believe with the little that we can do today, and then a link that I will give you at the end, you should be able to conduct a meta-analysis if you know how to do a systematic review. So they always goes hand in hand, and I always tell people meta-analysis is quite easy, especially if you are using CMA. The most important thing is to know how to conduct a systematic review, which we had a workshop, I think, a couple of months ago, and I think it should be on our YouTube channel using confidence. And yeah, that a lot has been covered about doing a systematic review. So if you didn't get the chance to join last time, you can go to our YouTube channel and then you can look at the workshop we had on conducting a systematic review. So I was saying we're gonna have a brief introduction on conducting meta-analysis, which goes along with a systematic review, and then few importance of meta-analysis, and then I will show some examples, and then we do the practical session which we can see practically how we can put data into the meta-analysis software. Okay, so to begin with, of course, meta-analysis is just a type of review, which some people categorize it as part of a systematic review, and then some people consider it as a research design on its own. So either way, you still need to be able to do a systematic review for you to conduct a meta-analysis. So, and generally, if we are doing a review, the basic one that we all do is the literature review, and which sometimes we call it narrative review. So in that one, there is no any structure. You just go to the internet or your sources of information and just put as many literature as possible the way that it makes sense to you. And then we have another category, which is the scoping review, which share a lot of characteristics with systematic review. So the only difference is that when it comes to scoping review, there is no restriction on what kind of articles or resources you can include. So it's kind of open, and the whole idea is just to scope the evidence around that particular topic that you're working on. And then comes down the systematic review. So as I said, systematic review, irrespective of the field, is the highest level of review that you can conduct. And that is why you can publish a systematic review in any journal. And actually, a lot of journals that publish systematic reviews, they even tend to have a higher impact factor. Impact factor, especially in the health field, which is where I am. So, and that is why systematic review is a very, very important research design that even though it originated in the health sector, and now it can be applied in any field. And that is why both systematic review and meta-analysis, you get to see them in different fields, even though it is not that common as it is in the health. So as I said, let's take meta-analysis as part of a systematic review, because if you have done a systematic review before, it's basically the same thing that you're going to do when it comes to meta-analysis. The only difference is when you come to do the analysis, you follow the key techniques of putting the result together using meta-analysis. So it's more or less like a step in your systematic review, the way you analyze the data, that makes the difference. That's why I say whether you take it as a technique on its own, it's still the same thing. And even if you take it as part of systematic review, it's the same thing. So let's look at the definition of systematic review. It is a scientific inquiry that relies on a focused question and a predetermined protocol to identify, critique, and ultimately summarize different primary research studies. And I think this is quite self-explanatory. We can see that unlike the traditional way that many people, especially in the science and social sciences, you go to people, you do your interviews, or you give them questionnaire, you collect the data, or you do observation, and then you put the data together, do your correlation, whatever, come up with the result. When it comes to a systematic review, you don't need to do all of that. You can sit in your room and then you can conduct a sound systematic review and get it published in a very, very big journal. And this is particularly important, not just for academics or people who work in the university, even those who are looking to apply for scholarship. As you all know, we introduced the Educational and Mentorship Forum just to guide people on how to get scholarships, especially for masters and PhD across the world. So one of the key things that is required, or for you to show that you have a strong background to get that scholarship, is publication. So there is no way you can get a scholarship without, especially when it comes to PhD. You can get admission without any publication, but when it comes to getting a scholarship, the competition is so high. That is why it's important for us to know how to do all sort of research and to be able to publish it so that we can use that research to apply for scholarships or even for admission in some cases. So that's why we thought, you know, if we give tell people how to do this systematic review, you don't necessarily need to go and even look for any ethics, because all that is not required. So you can literally, at least 2 people will be great to sit down and just come up with a topic and just conduct your review, and you can publish it and you can use it in whatsoever avenue you want to use. So the way it works is that, just like we said earlier, if you do a primary study, you more or less design a questionnaire, go to people, give the questionnaire to them, they fill it and give it to you, and then you sit and analyze the data and, you know, produce your study. When it comes to a systematic review, you use the existing research studies, the existing primary studies that have been published. So you don't need to go to anyone. So it's just about following a systematic way of doing your search in databases and then come up with the studies. And then once you're certain about the studies that will be included, then you just follow certain steps that I will show you in the next slide, and then synthesize your findings. So these studies will serve as your primary data or as your data for your systematic review. And as I said earlier, a meta-analysis is more or less like a quantitative, either quantitative study design or just a way of analyzing your data quantitatively from a systematic review. And that is why they go hand in hand. So as we can see here, it is a quantitative study design or analysis used to systematically derive a conclusion about a body of research with a precise estimate of an overall effect, or a numeric summary of an outcome. So all that you do is just to go for the specific quantitative values and then just put them together, and literally that is the meta-analysis. And we're gonna see how we will do that today as part of our practical session. So just to recap, these are some of the key steps that you can follow to conduct a systematic review, as part of which you can do your meta-analysis. So many literatures can put it in different ways. Some can say 5 steps, some can say 7, some can say 10, you know, and so on and so forth. The key thing is you will have to do all the different things in one way or the other. So it does not matter how many steps you come across, the key ideas remain the same. First of all, you need to have a research question, because if you don't have a research question, what are you researching on? What are you going to publish on? So even if you go for publication, they want to see that you have addressed a clear research question before they will consider whether or not to publish your article, especially if you go for international journals, which of course, if you are looking for international scholarship, definitely you need to start thinking in that direction. So, and then secondly, you just have your inclusion and exclusion criteria. Again, these are just set of criteria to say, okay, I'm doing a systematic review, I need to include primary studies. So what is the criteria for me to include a particular primary study? Because I cannot take every single primary study in the field of my research. I need to have certain criteria that will make it very narrowed, very specific to the research question that I am working on. So that is why you set this criteria. And then search for studies. So as we said, you don't collect primary data, so you just go to different databases. For example, if you are from the Healthline, we have Medline or PubMed. We have a lot of other databases that you can use to search for studies. And even if you are from other fields, there are bigger databases like the Scopus or the Web of Science that more or less they are general, but you can get a lot of studies from there. And then after you search for the studies, you're gonna come with so many outcomes. So again, you cannot include all of them. So you have to screen the studies, check their titles, their abstract to see that they actually contain the information you're looking for, and then you can select that study to be included as part of your systematic review and meta-analysis. And then once you have your studies, let's say you have 20 studies that you want to do your systematic review on, it can be as low as 10, in some cases even up 7, you can use them to do a systematic review. But the higher the number, the better, or the bigger your systematic review is going to look like. So these studies, you need to extract the information from their result, because the information you extract from their result is what you're going to combine to do your own research or to build your article for publication. And then before you synthesize the result, you need to assess the quality of the studies. And all of these, there are so many resources. You don't need to crack your mind to come up with how to do it. When it comes to quality assessment, there are a lot of tools that you can use. All you can do is just to look at the article. Okay, does it have a good research question? Does it have good sample size? It's just to tick, and then that will tell you how good is the primary study that you are including. And then finally, synthesize and present the result. So this is where, if you choose to do a quantitative or the best quantitative analysis for your systematic review, that is where you do the meta-analysis. And sometimes you don't even have to do that, but of course it won't be as strong as if you do the meta-analysis. You can just do a narrative synthesis, just build a story. If you included 20 studies, you just build a story. 5 of the studies talk about this, 3 talk about this, you just based on your specific outcomes. But for today, our main topic, as I said, is not about systematic review, it's about meta-analysis. So we're going to concentrate specifically how can we do the meta-analysis. Let's say you come up with a research topic, you follow all of these 7 steps, and then finally now you want to build your result, or you want to synthesize your result. This is what we are doing today. So these are just some of the importance of conducting a meta-analysis. It can increase power by increasing the sample size. If, for example, you did a survey in Nigeria and then somebody did the same survey, let's say in Ghana, and somebody, let's say, did in Bangladesh. So all of you, you did your survey with different population. So when you do a systematic review and meta-analysis, you're going to bring all of these different population together. So you can see the sample size is going to look big. And as a result, the estimated effect size is also going to be big, because you go beyond one country or beyond one population, and that can be as huge as, you know, thousands, because we did one study last year. I think when we put together all the population, it goes to over 1 million. So that is how big, you know, a systematic review can go. And then you can resolve uncertainty when conflicting results occur. So because you have got different studies from different areas, so if there are uncertainties, you are able to eliminate those uncertainties because you have got a lot of information. And then improve the generalizability of your findings. So imagine if you do a research in Nigeria, let's say you look at experiences of a student with taking examination in mathematics, for example. So you can't say you will generalize the result to somebody, let's say, who is in America, because different people, slightly different education. So, but then if you are able to take a study from America, take from Nigeria, take from China, you put all of them together, you can be able to generalize the findings because you put so many different things together. And then you can produce a precise effect size. And that is the key thing about meta-analysis, because you use a good technique to put the numbers together to be able to come with a precise single value. I will show you one example later. And then you can generate new hypotheses easily. When you put too many studies, if there are gaps, you can easily come up with new hypotheses to conduct new studies. Okay, so now we're getting into business, meta-analysis. So normally, you know, the name, sometimes it can sound like something very big, but to be honest, as I said, learn how to do a systematic review is the most difficult, but meta-analysis is very straightforward. because it's nothing but the way you present the result as a forest plot. I'm going to show you the plot in the next slide. And then there is something called heterogeneity, which again, I will explain to you when we go to the practical session. And then there is something called a funnel plot, which again is something less important, but some journals, they will require you to have this. So among these three, the forest plot is the typical characteristic of a systematic review, because it puts together all the studies that you include, and then it comes up with a single value that summarizes them. So that is why most of publications that you will see that forest plot. So I will show you in a minute how it looks like. So these are just some examples. It can be for intervention. You want to know the effect of a medication, or you want to know the effect of a fertilizer on certain crops, or you want to know the effect of some type of teaching, maybe online teaching compared to face-to-face teaching, all sort of things. As long as it's intervention, you can conduct a meta-analysis of different studies. And it can be on prevalence, which is one of the practical things that we will do today. It's just a way of showing proportion of something. So it's quite straightforward. Let's say there are different percentages, and we want to put the different percentages together to have a single percentage of proportion. So that is a meta-analysis of prevalence studies. And it can be on observational studies as well, so which I will show you another example. And there are so many other types. So as you can see on my screen, this is basically a meta-analysis. And this is a study that we published last year about depression and anxiety among general population in Africa. So of course, we all know Africa has so many countries. So there are so many studies even in Nigeria. There are so many in Ethiopia, in Ghana, everywhere in Africa. People conduct their primary research to know how many people get depression because of COVID-19. They can't go out, whatever the reason may be. How many proportion of people were having anxiety or depression? So as you can see, this is a typical forest plot, because this is this is the main characteristic of a systematic review. So at the end of the day, once we do the practical session, you can see we will come up with this. And once you come up with this, that is the systematic review. So as you can see, this is a list of so many studies. I think we included over 70 studies. For this particular analysis, we may have about 30 or 40. So you can see the first one is in Morocco, Cameroon, Kenya, all the way. There are a repetition of countries, which is again, okay, all the way down to Sudan and Tunisia. So all these different studies, people conduct them in their countries among a small group of population. But for us, we want to say in Africa, this is the proportion of people that have depression as a result of COVID-19. We cannot go to every country in Africa to collect this data. So what we did was just to sit down, okay, let's find studies that were conducted in different countries, and let's put these studies together so that we can get one single result through a meta-analysis to say, this is the proportion of people that have depression because of COVID-19 in the entire Africa. So as you can see, we have the numbers for different studies. And then if you come down here, the last one, you can see 0.48. So this is, if you change it to percentage, you multiply by 100, it's going to be 48%. So with certainty, we made a conclusion that 48% of people, or proportion of people in Africa, experience depression as a result of COVID-19. So you can see how we pull together all of these different studies to come up with 48% at the end. And this is what we will do today, because using percentage or proportion, this cannot be just for health. It can be for anything, as long as you use some sort of percentage to estimate something in your field of research. You just put together all of these different percentages, and then you can come up with one. So this is just one way to show a meta-analysis. And another one is sometimes you can have primary studies that have two groups, so it's not just one. In the previous case, it's just about studies that estimate the proportion of people with depression in Africa. So our research question is, what is the proportion of people that experience depression as a result of COVID-19 in Africa? And we put all of that together. But in this case, this is again another studies that we published 2 years ago. It's about comparing two set of people. So any study that compare two set of people that are healthy like me and you, and then people who had experienced stroke. So we want to see their quality of life. And again, when you're measuring quality of life, there are tools. It's just to ask people different questions about their family, about the food they eat, about their life, the way they socialize. Already there are tools. So people already did that research. So for us, we just collected these studies. So now we want to put together and see if we compare people that are healthy compared to people that have stroke, how does their quality of life compare between the two? And at the end of the day, we put together these 6 studies and then we came up with a single result, which is 1.134. So that tells us, and if you can see on this part of the forest plot, you can see that we have it favors healthy people like me and you, or the analysis favors people who have stroke. So obviously, if somebody has a stroke, as we know, it's a condition that leads to paralysis of a part of your body. So you can see that those that are healthy, their quality of life is always higher compared to those that had stroke. And that is why you see on the meta-analysis, this black dot, they go more towards the healthy side compared to the unhealthy side. And at the end of the day, this red one that you see at the bottom is like the summary. So it's just like saying you are taking an average of different numbers. Okay, all of you, let's say you are in one class, I give you a test and then you all score different numbers and I want to take an average of the whole class. So this goes in a very similar way. So we have different studies that compare two sets of people, and then at the end of the day, this red one is like the overall when you do a meta-analysis and come up with the result. So I know this again will sound more abstract, so we will try to do the careful about time, to run the meta-analysis together and then see how we can come up with this result, and then hopefully people will have better understanding. So this is a bit about my field, but then I was checking earlier, there are a lot of meta-analysis happening in many other fields. Of course, I am not expert to interpret those, but the key idea is the same: putting together different quantitative findings to produce a single outcome or a single result. So as you can see, this is in education that compare academic performance between blended teaching and something else. And then it's the same thing at the end of the day. You can see this is a forest plot and you can see different studies as they are moving. And then finally you see the overall result. And again, this is something I don't even know it exists. Again, it's a meta-analysis in the ecosystem engineering. I don't even know what that is because I'm not in that field. But the whole idea is, again, something like this came out and they're able to put together different studies to come up with a single result. Again, this is something about crop production. So you can see, because there are different machines to do meta-analysis, that is why the output, you can see it slightly, the design is different, but at the end of the day, the whole idea remains the same. And interestingly, there is a study in business that I saw. So they decide not to present the result using the forest plot, but they put it in a tabular form. And again, at the end of the day, the whole idea is the same. So to avoid wasting more time, I will just get into the practical session because obviously this is what brought us today, so that we can see how practically can you use the meta-analysis software to conduct a meta-analysis. So I will stop sharing this screen and then I will go to my meta-analysis software so that we can see how we can do it in reality. So I hope we are still together. We will answer
together,
questions.
Yes,
Okay.
Doctor, we are together actually. Thank you
Thank
for
you.
the
Thank you.
wonderful introduction.
Yeah,
It was quite interactive
just to be
today.
sure I'm not talking alone.
We are together, sir. We are together. We are here. I'm
Okay.
following you.
Lovely. So, anyone who is able to download the free version of CMA? Anyone? We can say yes or just thumbs up.
Yes, I have downloaded it.
Okay. Yeah, because sometimes the free version is always a free version. So
Yes. It's a
just
trial, I think maybe 1 week trial or something like
yes,
that.
yes. So normally they restrict the days, and then sometimes they can restrict the number of analysis you can conduct. But I'm sure for this workshop, we're just going to practicalize how to run a single meta-analysis, and it should be fine. So if you are able to download it, good. If not, I have it here how to, okay. If you want to do it, you can see here, okay, where is it? Okay, yeah, so you can go to the website, just you type on Google comprehensive meta-analysis, it will come, add your name and email address, click proceed to download, and they will send you email with the download link, and then go to your email, click on the download, and then you can, your download will start immediately, and then you can install it on your PC, and that's it. Of course, in reality, if you want to use the other version, it's a pay, you have to pay for it. But obviously, there are always ways to get it in this world of technology. But let's just use what we have for today.
Abari, some people are asking if Dr. Chutiyami can share the link.
Okay, the link. All right.
So I will share the link. Doctor, go ahead.
Okay, okay, thank you. Yeah. So he will share the link and just try to get the link, and then I will just go to my own meta-analysis software. And then you can see how we can input the data from beginning to the end. So I hope it doesn't give us trouble. So can you see my blue screen? Okay, can I see? Oh, you can see? Okay, another interesting thing. Let's see. Okay, I need to share again. So let me share the entire screen. I think it should be fine. So what about now? Okay, it should be sharing. So it should get to you. All good?
Yes.
Okay.
Yeah,
I have somebody next to me, so I just see to make sure that people can see what I'm sharing. So as you can see, if you download it, normally you can have the shortcut on your desktop. So you can see comprehensive meta-analysis version 3.exe. So all you do is just to click, double click, just like any other app, and you will see this. It's coming, right? Okay. So for those who have it on their computer, are you at this stage? Okay, so once you open, so it's going to ask you, do you want to start a blank spreadsheet? Do you want to open an existing file? Let's say I started the analysis yesterday. You can save it in its comprehensive meta-analysis format and just come back to it and then go to your file and then bring it back. So otherwise, if you want to start fresh, and another way to do it, you can actually arrange your data in Excel and then copy and paste it. But today, for the sake of understanding, we will just start it on a fresh page. So you open your meta-analysis, and then you just click on start a blank spreadsheet, and then you go for OK. So I hope we're still together up to this stage. So the next thing is, this is the interface. It just looks like Microsoft Excel. It's just that obviously it has some other options. So the first thing that you need to do once you open the software is to go to File, insert, because we are not using an existing file. If it is existing file, we just go to file and then we go to open, and it's going to go down to our computer, and then it will enable us to take the file. But in this case, I said we will do it just fresh. So you go for insert is the first step. I will give you a link with that you can see all of these steps at the end. So just if you have it on your computer right now, just keep going with me, because we're going to put the values together. So you go to insert and then you go for columns for study names. Remember, we said meta-analysis, we are putting different studies together. So of course you need the study names because this is your data. So you are not giving reference to people who take part, you are giving reference to the entire study. So you insert column for study name, and then you go back to insert again, and then column for, if you scroll down, you can see effect size data, because that is all you need. You need your studies, the name of the study, just to identify which studies are there in that particular meta-analysis, and then you need the effect size. So you click on that. Are we together? At least, I hope one or two people, if not all, are following, because I feel like if you just do it practically, it's a lot easier when you come to do it later rather than we just talking and you watching. Okay,
Yes.
so once you click on insert studies, you will see that it will open a small box. So it will say show common formats only, show all 100 format. It's okay, you can go with any option here. So let's leave it at the 100 and you click on next. So once you click on next, you will see there are 4 different buttons. The first one says comparison of 2 groups. The next one, estimate of means, proportions, rates in one group at one time. And then the other one, generic point estimate or generic point estimate and the log scale. So all of these are a big category of how you can improve numbers. So we are all from different fields, and there are a lot of ways that quantitative research is conducted in our field. And when it comes to meta-analysis, all we are doing is to go to these primary studies, look for that specific data, and then take it and put it into your meta-analysis. So for today, as I said, doing the basic one, obviously we're introducing it, and it's going to be like a proportion. So if in your field there is a study that people can use percentages to estimate the proportion or the percentage of something, which in medical line we often call it prevalence. So this is what we are doing today. So if you look at it, it comes under, so you can play with all of this. You can try anyone you open, then it's going to expand. So you can see the one we are doing today goes under the second one, estimate of means proportions, because we said we want to put proportion. This is a reference to the study that I told you we did last year, whereby we look at the proportion of depression due to COVID-19 across different countries. So I selected 5 studies and we're going to practicalize on this. So once you click on that second one, you go for next, it's going to open another dialog. So you can just click on the first one, dichotomous, you can see raw data. Because there are hundreds of ways you can estimate your research, or you can put your research in number. That is why you have a lot of options. So if you click on the raw data, you can see events and sample size. I hope we're still together up to this stage. So remember, we said what we are doing now is just to estimate proportion, proportion from different studies and put them together. So you will not necessarily see it as proportion, because if we say proportion, is just like saying there are 20 of you here, I give you a test, and then those of you that pass the test get at least 50% and above. It's only 5 people. So I can easily say, out of 20 people, I have 5, that pass the test. So the proportion of people that pass the test is 25%, because it's 1 out of 4. So it's the same thing. So we're going to use event which is, for example, the number of people who passed the test and sample size compared to the general class population. And that goes in any field. If it is something that you do on crops, and then at the end of the day, you want to see the crops that yield the best output, so you can just estimate how many of those have the output compared to the general crops that you put the experiment on. Sorry, I'm not in that field, so just trying to give an example. So if you click on event and sample size, and then you click finish, so it's going to expand itself, and I hope we're still together up to this stage. So now we are set to do a meta-analysis of proportions or percentage or prevalence if you are from the health field. So now we need the data, because this is the machine. Whatever we put, that is what the machine is going to get us at the end. So now we need to go to our source of data, which we said is not people, but the primary studies that had been published already. So what I will do is I already put the primary studies here so that it will be easier. So I'm just going to paste. I will share it. I have the articles with me, but I will just share this on the link in case if you want to find this article, so that you can see specifically where we're going to get the numbers. Because if you open an article, you're going to see a lot of numbers. So you only need something specific to do a meta-analysis. So I'll just share. This is one of the articles that we're including. So I'm just sending you the reference. It has a link. If hopefully you can be able to click on the link and download the article, that will be good. Otherwise, I will just open the article and then we will go through it. So it should be here. So we are going by, we now want to go and get the data to put into our meta-analysis software. So can you all see the article I'm sharing? Is it sharing? Okay, lovely. So remember, what we are practicalizing now is just to see the proportion of people that have depression in Africa. And there are many studies. So our first study was conducted in Ethiopia. And that is only among a small population of, as you can see, 420 respondents in Ethiopia. So this article assess something about depression among this particular population in Ethiopia. So one interesting thing is, when you are doing a meta-analysis, you don't expect to just go to the article and see that information you are looking for just straightforward. You have to go around in it and then find that particular information. For me, I said I want to see the proportion of people that have depression due to COVID. And if you look at the title of this article, it says the magnitude of psychological problem and associated factor in response to COVID-19 pandemic. So this says psychological problem. So this is a bigger term, okay? I knew there will be depression somewhere, but I don't want to put a figure that estimates the entire psychological problem, because remember, we said the first step in your meta-analysis or systematic review is to have a research question. So my research question is looking for depression, so not psychological problems. So I have to begin to see, begin to search from the abstract. Can I see something? Mostly, if you're looking for data to put in your meta-analysis, you go to the result of your study. Sometimes that can be in the abstract. Sometimes you have to go to the actual result section. So let's look at the result here. It says the magnitude of psychological problem from moderate to severe levels was 66.4%. So this one, it says psychological problem. Remember, my research question is depression. So this does not solve my problem. So now I have to scroll down this massive article, just keep going down. I'm looking for where I can find information on depression. And I need that single number that estimates depression. This is what I will put into my meta-analysis software. Otherwise, if I put for the psychological problem, it's going to give me an estimate of all psychological problems. So you have to look for the specific information. So if I keep struggling, I mean, you can keep searching. Of course, you're going to get used to the articles if you do an actual review, because they are like your participant. So you're going back and forth, you will be familiar with it. So if you just keep looking, you can even do the control find and then just go for where it says depression and just look for your data. So mostly I go to tables or chart, because normally in field research in social sciences, always they will present it in tables or in chart, just to make it easier. So if you come down here, you can see under this figure 1, we have this histogram or bar chart or multidimensional bar chart. Whatever it is, what I want here is there is something about depression. So as you can see in this chart, it says all green is estimating stress due to COVID-19. All red is estimating depression. All blue is estimating anxiety. So at this point in time, I only want information on depression. So it does not just tell me like this is one single information. And remember, in the meta-analysis, I cannot put too many things from one study. So I want that single information about depression. So if you look at it, it says all of this red is about depression. So it's just that it put it as normal, which means they don't have depression due to COVID-19. Mild, they have a little bit of depression. Moderate, you know, it's just at the middle, and then severe, that is high. So I can say confidently from this chart, the number of people that had depression in that part of Ethiopia include those with the mild, which I can see 186. So I will just take my calculator, because I need to estimate this number. Remember, in our meta-analysis, we're going to put event and sample size. So we want to accumulate all of these numbers. So from here, you can see that if you just go, just obtain my calculator. Okay, those that have mild depression is 186. And then those that have moderate depression is 34. And then those that have severe depression, they are 18. So if you put them together, we have 238. So this is the event. This is the number of people who have depression in that part of Ethiopia. So remember, we said we need that one, and then we need the sample size. We need how many? All of them, including those that don't have. So this, it clearly said at the bottom of the figure, N equals to 420. So the total population is 420. Out of them, 238 have depression. I hope that makes sense. So now I'm going back to my meta-analysis software, click on it, and then, okay, this study, you can give them any name, depending on what kind of referencing style you'll be using for the journal you're targeting. So it can be APA, it can be whatever style you want to use. So let's say this study is called, the first author is Kassau. So I can just come here, and then under study name, I can put Kassau. And then what is the number of events for depression is 238. And what is the total sample size for this study is 420. So this is all that I need from that study to know about depression. And you just click anywhere, automatically you can see meta-analysis is estimating the proportion now. So out of this already, the software has estimated, okay, 56.7%, which is 0.567, they have depression in this study. So now I am done with this study. Is it clear? Yes? No?
Yes,
Okay.
it's very clear.
Thank you. So
Yeah, very clear, very clear.
Clear, sir. It's
lovely. Okay, so now we're going to go for our second source of data. So I have another, okay, let me also share this if you want to find the article. So I'm just going to share this in the chat as well. So if you want, you can just open, otherwise you can see the one that I have. I just go to the second study. So can you see the second study that is from in you, whatever that name is, which country. Yeah, again, this is in Ethiopia. Again, it's fine. You can have multiple from one country and then one or two from other countries. It's still okay. I will tell you something about this as we go on. So again, this is another article that estimates psychological impact in different parts of Ethiopia. And this one used a total of 302 nurses. So this is not even about the general population, it's basically on nurses. And remember, my research question is just what is the proportion of people that have depression in Africa? Can be health professional, can be pharmacists, can be anyone. So any study that estimates that is part of my included studies. So now I'm gonna look for depression from this study, how many people have it. So if you look at this under the result, the prevalence of anxiety, depression, and stress among nurses was 69.6, 55.3, and 20.5 respectively. So which means for depression is the 20.5. So already this one put it as a percentage. So ideally, if you can, try to always get the raw number. If you cannot, the good thing with comprehensive meta-analysis, it has the ability for you to enter studies that have their estimate in different way. So now if I like, I can just go and put this percentage, just need to do a bit of modification. But before that, let me see if we can get the exact number of event and then the sample size. Otherwise, we will convert this 20.5 into how we can put it in our meta-analysis. So we're just going to scroll down to the results section. We're looking for depression, proportion of depression. So here, again, it says, oh, okay, probably. So again, sometimes you can get a lot of information that may not necessarily be useful to you. This one, they are probably comparing with a different data entirely. Because here it says those with depression is 55.3, and then up there I think it says, let's look at it. Oh, it's the same, so 55.3, so it wasn't 20, pardon me. Okay, so let's see if we can get the exact number of people, otherwise we will convert this number, 55.3. So let's see, is there anywhere we can see depression? Anywhere. So you see, it's not like the other one that provide the number, and that is one for meeting with the primary studies. Everyone do their own study in their own way, so they don't care whether you're going to use it in your own review. So now we just come back, okay, all that we have is that number that says 55.3, which is obvious, yes, they have depression. So, and then out of 293. So I'm sure we have so many mathematicians here. So out of 293 people, but we have to be sure this is the total sample size, because one thing with meta-analysis, easily you can miss the numbers and that is going to make impact on your analysis. So we have to be sure this 293 is not just a reflection of 53%, whether it is a reflection of the 53% or whether it is the total number of participants. So again, I can go around and then see at the beginning of the result, how many people did they say? So you can see a total of 293, which means this is all of the participants. So who can help us? We have 293 people and then 55.3 have depression. So if we're going to estimate in terms of raw number, how many people will have depression?
I think it's 162. I see Abakar Sadiq commented.
Okay, thank you. So let me just 55. So sometimes you just have to work out these little numbers just to come up with what you're looking for. So let me see, time is 293. So how many?
162.
Yeah, 162, thank you, yeah. So I got the same thing. So now I have 162 and then I have 293. So now I'm gonna go back onto my meta-analysis and then go for the second study. So the second study, I said the name is Mekonnen. You can always come back to it and change the names or whatever, put it in reference format the way you want. So Menakon, whether it's right, this is just for demonstration. So we said we have 162, and then we have 293, right? 293. So I just go to the next one, automatically it filled up the rest of the information. And now I'm gonna go for, so remember, even if you have 100 studies, this is how you're going to follow them to get the numbers for your meta-analysis. So, but here I just leave it as 5 so that we can use this for our demonstration. So I'm just going for the next study so that we can get all the data as soon as we can. Okay, Ofori, Anthony. So this is somewhere in Ghana. Okay, so we have 2 from Ethiopia. Now we have this from Ghana. So let's look at this. This is psychological impact again, and now we're looking for depression. So let's look at the result. 40% of respondents had fear, while this had depression, anxiety, and stress. So we have 21.1%. So before we do the conversion, always we want to see if we can get the raw number, because of course, those of you that are in mathematics, you know this better than me. The more you do conversions, the more likely you're going to lose some value in your numbers. So you want to get the specific one if possible. So let's see if we can get anything about depression in this study. So depression, we're looking for the percentage. Okay, so let's come here, depression score. And sometimes, if you're doing field research like this, you can see that the total number of participants can change based on that particular information. So here you can see under depression, they assessed that among 271. But when it comes to anxiety, it's 270, which means when they were doing the primary study, somebody decided not to answer that question, which is still okay. So you need to use this 271 if you are doing depression. If you want to do meta-analysis on anxiety, your total number should be 270. The same thing if you want stress is 268. So it's good to pay attention to this key information. So here we have total 271, and then let's see, now we went to estimate how many people have depression. So none, 214. So here we have, you can estimate and put in the chat to make sure I don't miss it. 31 plus 12 plus 11 plus 3. So 57. Anyone else got 57? So I'm just going to go back to my meta-analysis. I have 57, I have 271 people. So this one is something like Ofori. You can put it all, you can put the date, whatever you want to put. You will see how it's going to come out. So we have 57, and then we have 271. So now I'm gonna go for the 4th study. So the 4th study is Federi. Or just before that, let's get the other study. You see. So let's look for the same thing in this study. Mental health status of you. So you can see how this one put their title. They didn't say depression, they just say mental health status of healthcare professionals. Again, when you do search, please go back to our webinar video on systematic review if you want to see how to do search, or probably we can do that another time. So if you come up with this article, it means the system knows there is something about depression that I'm looking for. That is why this article is included. So it's just for me now to go through this and then find out where is the information. So let's look at the result. 540 healthcare professionals participated. I don't care about all of this other younger age, whatever. I'm just looking for something on depression, and I just go through it. If I can find depression. Okay, depression and anxiety. is here, but then as you can see, is the estimate is completely something just beyond percentage. So there are instances that I can use them, but for now I just want that proportion, nothing else, which is the same thing that we do on that study that I showed you earlier. So let's come down to the results section. Let's look for where we can see depression. Okay, we're looking for depression. Okay, so if you look at here, we can see that we have got normal 2 to 1, and then we have got at the middle, if you look at under depression, so we can see we have mild depression 93 plus moderate depression, we have 122 plus severe depression, we have 53, and then extremely we have 51. So that gives 319. So now the question is how many, what is the total number? So 319. So now I need to be sure how many people all together. So can I find it here? So here it says quarantine, but it's not quarantine. I want the total number, so I will go around just to find it. You will never see information straightforward, so you just have to work things out. So let's see. So you see a total number of 540 respondents from whatever. So here I know this is the total number. So I'll just go back to my meta-analysis, and this is use safe. So I have 319, and then I have, is it 520? 540. So 540. So I just go, and then I will go for the last one. So the reason why I leave this for the last one is just to show you what if one study, there is no way you can estimate the number of events as we did for the other study. So that's the good thing with meta-analysis, that comprehensive meta-analysis software, that many other tools, at least the ones that I know, you cannot. You just have to make sure, you have to find a way to all put them in the same format. But this one, it has the advantage. You can put it in a different format if there is no any other option. So let's look for our stress. This is the last study. Let's look for depression. So we go for depression. Let's get down to the results. So we're going to put this in the percentage that it is. Okay, so this one too, it has the individual one. So under depression, we have got 430, 47, 95, 46. So let's say there is no way to estimate, because sometimes when you do meta-analysis, you can see that some studies, because it's not just about percentage, can be correlation, can be regression, can be whatever quantitative analysis that you do. Let's say I just can't find anything. All I can find is just a rate which says 57.3, which if I take it in terms of percentage is 0.573. So if I want to put, I'm just going to show you this as an example, so that if you come across studies that don't have the same way of reporting, you can do it SEDRI. So let's say SEDRI. Okay, before I put SEDRI, okay, now let's say I want to change the format that I'm putting these numbers. Let's say this study did not give me anything like the other ones. So I still go back to insert, and then go to column 4, go to effect size data. So it's going to take you back to where you were before. Okay, before I put my data as event and sample size. So let's say now the next study does not give me that. It only gives me, for example, let's say event rate and sample size. So all I can do is just to click on that, finish. So you can see the meta-analysis software, it adjusts itself and it blocks the other studies because already you put their numbers. So now you're going for another study called Sederi, but Sederi we assume does not have the event as we do always, but it has event rate. So that is why you can see on the top, it also changed from event, it says event rate. So let's say Sederi's event rate is 0.567, and then the sample size, let's say, is 400. And then if you just click on OK, so that's the good thing with meta-analysis. At the end of the day, this yellow section is what is going to come out for your meta-analysis. So you see, despite the fact that we put the last study in a slightly different format, still the outcomes, it comes back to the same. So meta-analysis have that comprehensive meta-analysis software has the ability, you can have 10 studies with slightly different way of reporting their data, and you can put them, if it is statistically possible, meta-analysis is going to convert it to a single outcome measure. Because at the end of the day, I want a single number to say this is the summation of everything. So it has that ability. That is why you can always go back inside and change the way you put the number and come back to it. And if you want to, let's say, okay, now I put this, I was like, oh, now I have another study with the same one like before. So if you remember CASA, I just click on it, and that's more than enough. I just put another study, let's say AAA, and just already it comes back. I can just put my event, whatever I want to put, and just it will just continue. So you can play with it as much as you want, and anytime you can change it, you can delete. Let's say now I want to delete this Sederi, you just click on it, and then you just go to edit, and then you go delete row. So if you make a mistake, you don't need to do everything all together. You just go back to it and just click on the first one and go to edit, and then you can just delete the whole row. So simple as that. So let's just put our Sederi. Let's say we want to put Sederi is the last study. We're just going to assume this number so that we can save time. So let's say the event rate is 0.567, and then we say the total number is 400. This is just for demonstration purpose. So let's say now these are the 5 studies that I can find in Africa that estimate the proportion of people with depression. And I already got the specific information for depression from these 5 studies, and I put them in my CMA software, and now I'm ready to run the analysis and come with that outcome in form of graphic that we saw earlier. So it's so simple. You just go down. Now you, of course, if you do real study, make sure you double check the numbers and see that you have input the right number. That is why normally if you do a systematic review, most of the journals, they will require people to be at least 2, so that people can double check to make sure you don't make a mistake in terms of how you put the number. So you see here on top, run analysis. So now it's going to run the meta-analysis. So you just click on that, and then you can see. So literally, this is the forest plot that we said earlier. It's the same thing, that we have seen earlier. So now it has run the meta-analysis, and this is the summation of the effect. And here you can see 0.53. So according to the 5 studies in Africa, studies from different countries, the proportion of people with depression is 53.2% or 0.532, the same thing. So here, you begin to, look for few other things. So there are things like the fixed effect and the random effect. If you look at this yellow line, you see fixed. If you come to the bottom of the screen, there is random next to the fixed. If you click, then the yellow has changed to random. So this is important if you are doing a meta-analysis. When you have fixed effect, it's just the way you model it. So fixed effect and a fix is always if the studies that you included have very similar populations, similar kind of approach to do the primary study, like the similarity in them is very high. so that the chances for differences is very low among them. But in my own case here, I took the studies from different countries. I don't even know the researchers, but we just put together the data from different countries of Africa to come up with this. So always, if you have case similar to this, go for the random effect model. So it's just taking into account the key differences that is possible across these different studies, and is going to put them into consideration to make the estimate. That is why at the end of the day, if you click on fix, because the certainty is high, you can see the overall result is 53.2%. But when I go for random, because it takes into account these key things, it reduced to 49. And that is why, that is the precision we're talking about. So people develop this software, it takes into account all of these different factors. So that is one thing to note, fixed or random effect model. So if you just can remember, go for the random effect. Okay, so another thing, if you remember earlier, I said, when we do a meta-analysis, we basically look at three things. One is the forest plot. So this is the forest plot. We're gonna just click on this high resolution to make it in such a way that you can copy and paste it in your article. So if you click on high resolution plot, you can see how it comes out. So any study that do meta-analysis, or mostly, you're going to come up with this, something similar to this. And from here, you can just keep playing with it. Anything that you think you want to change it, you want to put it into another color, you just literally click on it. You don't have to do this, but then you can always do it and just click, and then you see things can change. But this is all graphics, you don't have to do it. So now you finish your forest plot, and then now you want to take it, because you're going to put it in your article. That is why you will demonstrate to the journal you have done a meta-analysis. So the way you do it is you just go to file, and then you export it to Word or PowerPoint, and this exact thing is going to come out as a Word document or as a PowerPoint document. So let's see. So you can see this is in Word document. So already it comes out as meta-analysis. So let's go back. So before we talk about how we will interpret this result, let's get the other key important information. So forest plot is the biggest thing in meta-analysis, and anybody that see this knows you have done a meta-analysis. And for this particular outcome, you have 5 studies that were included, and then this is the individual information about the 5 studies, and this is the overall estimate, 0.49, which if you multiply by 100 is 49.2%, which means based on these 5 studies from Africa, 49.2% of the people have depression. So single number to represent these 5 studies. So before we come down to that, let's go back to the table where we are before. You see, click next table. If you click on that, this is another important information. So as I said, you got a lot of information, you don't really need it. You can publish your meta-analysis using your forest plot and this area that says heterogeneity. This is very important. Any field you do meta-analysis, try to put this information under heterogeneity. So here you have 2 key information. One, you have the Q value, the other one is the I square. So this, it says heterogeneity. The assumption is that these studies come from different countries, from different people, different population. And in fact, even the research method can be slightly different. Maybe somebody use, experimental probability sampling to get the participants. Somebody use convenience. All of this make the studies heterogeneous. So this is what these numbers tell us. So normally people actually prepare the I square. So when you have the I square, normally any meta-analysis you conduct, you're going to get some numbers. And the minimum that you can see is mostly at least 25%. So the lower the I square, the less heterogeneity or differences among the studies that you combine. And the higher the number, the higher the heterogeneity, up to 100%. So you can see this one, it goes to 96%, which tell you, oh yeah, there are massive differences among these studies. So most of the time you don't really do anything. You just acknowledge it in your limitation of your article. Okay, even though I was able to estimate 49% percentage of proportion of people with depression in Africa, there is considerable heterogeneity across the studies. The I-square equals to 96%. And I will send you the link to our article. You can see how to write it. You just put it under the figure, you say figure 1, forest plot, and then this is estimate of depression among general population in Africa. The I-square equals to 96.25%. So already people know, okay, yeah, there is heterogeneity in your meta-analysis. And then for the Q value, which is again a different way of estimating the heterogeneity, normally this DF is the degree of freedom. So if it is above that degree of freedom, it means there is a big heterogeneity. And the p-value tell you if this difference is significant or not. So you can see 0.000. So as we all know in the basic statistic, anything less than 0.05 is considered significant, and anything above that is not significant. So sometimes you can put all of this information in your study. Just when you report the finding, your forest plot, you just open a bracket and put the Q value equals to 106, DF, which is degree of freedom, equals to 4, and then the P value is 0.00, and then comma, your I-square is 96. So this alone is enough to show there is heterogeneity in the studies you put in your meta-analysis. And this is the main key important thing that you need in your meta-analysis. So the first one is you already put the numbers, you select random or fixed effect. As I said, random is always the case, and then you take your heterogeneity. So which shows how different the studies are. So if I go back to the next table, coming back to this again, sometimes there are so many things to play around here. This Z value is not really important in this case. It's just showing the difference between, when you are testing null hypothesis, you have your expected numbers and then you have the actual one that was reported. So it's showing the degree to which these two differs, which we don't really need it. So you can actually delete it if you don't like it. So you just go to customize basic stats, and then it's going to show you, you can just remove the Z, you can remove the P, and if you want for demonstration, you can just put it, it's not a problem, apply, and then okay, and it's gone. Because you want to make it as clear as possible. So these are the information that you need. So if you, another thing before I get to the next page is sometimes some journal, again, many journals don't really care about this, is something that is called publication bias. And this one is trying to say, how if one study is very little sample size and another one is big sample size? Are you just going to all estimate them as one each, or you're going to give more value to the one that has more sample size? Which in reality, if you have bigger sample size, the authenticity of your result is higher there. So this funnel plot is going to show you if there is this problem. So from here, you just click on analysis, you see publication bias. So as you can see, as I said, many studies, you don't really have to report this. And even if you have to, you just save it and just put it, funnel plot, there is publication bias or there is not. So what we are saying here is, remember, we have 5 studies. So this dot is representing the studies. We have one that is just very close here, and then we have 3 inside, and then we have on the other side. So normally a study with very similar number of participants or whatever you are estimating, it should remain inside this inverted funnel. So if you have everything inside here, and this middle one is your overall 49% that we found, this is the middle number. So ideally they should be closer to this. So normally if you have studies with small sample size, they will tend to be toward the bottom. And then if you have studies with bigger sample size, because it shows they have more value, they will be towards the top. And they will be as close to the middle line as possible. So as I said, you just report it, you just save it and just put it. Funnel plot, there is publication bias because already we can see this and this study, they're outside. So which means they are so different in terms of the population that they included. So this is just by the way, okay? So we go back to our table. Okay, go back to the core analysis and then coming back to this, as we said, this is the most important thing. And then as I said, now we remove the z-value, which isn't that important. And now here we have for the 5 studies, we have the overall estimate, we have this is the confidence interval. So I'm sure many of you that do quantitative research, confidence interval is very common, and we all know the acceptable one is the 95%. So if we'll take the first study, CASA, we have 0.56, which translates to 56%. So the confidence, the 95% confidence interval, or the range by which the probability that this 56 will fall into is between 51.9% to 61.3%. So that is why it's important to always leave your confidence interval. And depending on the different studies that you are doing, you can always add the things that you want to leave in your meta-analysis. But for this proportion, this is all we need. And we're just going to save it. That is all that we need to do. So, yeah, I think we seems to be on time. So I will just go back here and then now I think it's time for us to answer questions, because this is a basic demonstration on doing a meta-analysis using CMA. So as we said, you can have intervention studies look at the effect of something on something, and you have 2 groups, and you can just the same thing, go to insert, and then you just go and look for, always when you go to insert column 4, you just go and then go to effect size, and you can always select what really works well for your study. It can be means, it can be mean and standard deviation, it can be other things like confidence interval, standard error. It can even be other things like, it's just a lot. That's the good thing with CMA. It's going to lead you to so many options. Okay, so I will just stop this and let's see, answer some questions, because this is the meta-analysis. All of us have conducted this together. So I talk, so let's see. Any question?
Thank you very much, Doctor, for this wonderful presentation. I think all audience will agree with me if I say the presentation is well executed. And in case you join us late, Dr. Chutiyami is an expert in public and infectious disease, and he has published several articles on systematic review and meta-analysis. So it's not a surprise that the presentation looks so simple and easy. I think a lot of the audience will be happy and will try to replicate the presentation. And again, I think this is a very wonderful opportunity for especially graduate student in Nigeria, where there is a limitation of experimental equipment. So always you can try to use this kind of techniques in order to publish your own article in high quality journals, so that you can get a lot of opportunities across the globe. Thank you once again, Doctor. And finally, we are going to entertain some few questions, because Doctor is somehow busy. So I think we can answer 2, 3 to 4 questions. And the rest of the question you can direct it to Gmail address, and then inshallah, on his free time, Doctor will respond to a question eventually. So I will start. There is someone, Hawa. If you are here, you were raising your hand earlier, so you can ask your question. If you are not here, then I we'll go to the next person. Okay, then Ali Isaac.
Yes, thank you,
Uh,
Doctor, for the wonderful presentation. Actually, I'm hearing this for the first time, this meta-analysis. It is quite interesting, and in fact, I'm presently working on one systematic review. So I think this meta-analysis will really help in my presentation, in my discussions and presentations of result. Sorry, I want to ask, Doctor, if I don't know, for some of us that are doing purely experimental, we have different operating parameters or different operating variables. For example, pH, temperature, maybe hydraulic retention time, and the rest. Now, so if you want to do this, if you want to use this meta-analysis, is it possible for us maybe to have several operating variables and compare them with your results? Maybe you have worked on so maybe anaerobic digestion or something like that. So maybe you have various operating parameters that influence the performance of your result. And is it possible for you to compare your results with the operating parameters you used during your study with other operating parameters or with other operating variables in other studies, maybe to come up with something like this? Is it possible? Thank you.
So the thing is, if, let's say you have the two studies and then the parameters are similar in the two studies, because what the meta-analysis does is just like to put two or more similar things together and then present them as one. Or if you want just comparison, it's going to compare. Let's say this study has a comparison between two parameters and another study has the same comparison between two parameters, maybe done in different setup or whatever. So meta-analysis software is always looking at this similar thing that were done across different points or with different setup and just see how does the two put together. So I'm not from the field for me to understand exactly what these parameters will mean.
Yes.
But if you can have two studies that have these different parameters, let's say they have temperature, pH, whatever, so you can do a meta-analysis just for temperature. So get the temperature of all the studies, and then do the meta-analysis for all the pH, do the meta-analysis for all the whatever. So you just have to break them one by one, and then you can do the meta-analysis, whether to compare them or whether to put them together and get a single result at the end. I don't know if that makes sense.
Yes, it really makes sense. Thank you.
Yeah, so lovely. And the good thing is, always I will recommend, please, if you are like you now, you already working on a review, so try to find a similar review in your field, because you will get more easy interpretation, because a lot of people, are doing this. So if you see something in your field, it's a lot easier for you to connect. For example, now, if anybody is doing in the health, nursing, medicine, whatever, easily I can interpret it because I am doing the same thing. So try to get this kind of sample. And yeah, just remind me, I will give you one link to show you the step by step. If you want to do it later, it's going to tell you the same thing that we do today. Click on this, click on that, put this data based on the different studies, if that will help.
Okay, that is lovely, Doctor. We'll be expecting the link.
Yeah, I will
Thank you
put
so much.
Yeah. So let's
Thank you
take
so much.
our next question will be from Usman Shehu.
Okay.
Usman Shehu, you can unmute and ask your question. We are not sharing Usman Shehu. You have to unmute yourself.
It's one of my mentors, for those of you who don't know Usman Shehu.
But we
are not into that.
You have to unmute your mic, Usman Shehu.
You need to unmute at the bottom of the screen.
Yes, we are not hearing you. Okay, I think before he figure it out, we can move to Nuruddin Muhammad. You can ask your question.
All right, thank you. And good afternoon, good morning, good evening to all.
Good evening.
It was really a nice presentation. But my question, since Dr. Muhammad introduced to us a little bit of some part of his lecture about systematic review, I have a concern or a little question that I'm not sure of, and I would like him to clarify.
Please go ahead and ask your question.
Okay, so one of the questions, when you are trying to have a systematic review, I have done a systematic review, I've gotten it published, but I was told that if I am going to do another systematic review, the topic, there is a database that I need to register for someone not to maybe, or if I register the topic maybe might be like locked up. Another person would not take the topic or continue, or if it has been taken, I will be notified that someone is currently carrying out a review of that nature. So that's my first question. The second question is, if you do a systematic review, like for us, maybe in Nigeria, I did mine when I was in Nigeria. So I did not cover all the databases. Can I still, on that same topic I've done, now that I have access to a lot of databases, can I still have another systematic review on that same particular topic, but covering a wide database? Then 3 is with still regard.
You will remind me.
Time,
Yes.
so maybe we can stick with these 2 questions, please. The last one you can direct it to our email address, please. Let's
Yeah, we will answer questions.
That's the last one.
Okay, so no worries. Okay, I'm
Thank you
waiting.
very much.
Just mindful of the time. So yeah, to answer your question, well, I can remember the second one now. Yes, if you have done a systematic review before and for whatsoever reason you did not get enough data, and access to many databases, because the whole idea of systematic review is, if you have your research question, you need to try as much as possible to see that you have captured all the articles around that topic. That is the key. Okay, so let's say you did it, you only got access to some few databases, and now you think if you do your search, you're going to, let's say before you only got like 10 studies, and now you realize if you do, you're gonna get like 20 studies. You can absolutely do that, because the number of studies significantly change. And sometimes you may somebody may have conducted a systematic review 10 years ago. Now most studies have been published, so you can again do another systematic review and meta-analysis just to put all of them together. So you can do it together as long as you have either slightly additional outcomes or you have more studies to include. So that was the first question. So the second question, I can't remember.
It's about,
I think
registration.
Prisma registration, I think.
Yeah, so I think he was referring to make sure that you're doing the registration and nobody else is doing the systematic review. I think, is that right?
Yes,
Just
yes.
that you registered and people know you are working on this. So normally, Prospero is one of the registers that you can do your registration. And the whole idea is, one, to make sure you're working on this review and no one else is working on it. Okay, so you don't need to duplicate. It's not like primary study that I can do the same depression in Nigeria, somebody can do it in northern Nigeria, I can do it in southern Nigeria, like that. Normally, systematic review, you don't want to repeat exactly the same thing unless there are changes in the outcome or number of studies. So you can register for that reason. And another reason is to make sure you have a pre-existing plan so that you reduce your bias of doing your systematic review. So for that reason, again, you can register it. So for those of you who are not in the health field, because Prospero only takes health-related systematic reviews, there is this OSF website, Open Science Forum, is free, and I will just put it in you can register it. And normally, if you have registration, even the journal is more likely to publish your systematic review because they feel like you maintain the standard by registering it. So this OSF, I just send it in the link. You can register any review from any field. And once you register, you can get a link to put in your article. Okay, I have pre-registered this review prior. So I hope that answers the question.
Yes, thank you so much.
Thank you very much, actually. It's very important. So I think next we go to Usman Shehu. Now you can unmute and.
Okay, thank you. One of my questions was already addressed, and as the doctor said, I'm his mentor. We are just classmates, and we are happy that one of us is making this kind of presentation. Actually, we feel more it's like somebody from us. This is really good, and we pray we have more of you. One of the questions I want to solicit, it has been addressed already. The request something of this that will require practical. We wish if you post the link so that we have the step by step so that we put it into practice, because this one going is not going to be adequate. And secondly, I want to also solicit something of this nature that will simplify our effort. If you find one, we will appreciate if you look for more of this from your side, if it's possible to have it presented to us so that we have diverse, in case many of us are in different field, and this is going to be just a beginning. We have a means of inviting more people so that we have diverse approach that will accommodate our various form of studies.
Thank you, Usman. So I said
the funny part of it, Mohammed, I know you are taking coke. This thing yellow, is it yellow coke or is something again?
As usual, nothing changed, so you guess right. So yeah, I will send you a link. It's just I'm just trying to find out where did I put it. The link has a demonstration officially from the CMA developers that you can actually click based on different kind of studies, and it gives even more detail step by step, which you just need to see, click, and just do it. So I will share with you this link. And again, in terms of doing the review, we will see if we need to organize another thing, maybe on how you can do the systematic review, probably. So is that the link? Oh, no, not the video. So yeah, I'm just trying to get the link. So yeah, we will, if at any time, if you have questions, as Buhari said, please send it to our site, or of course you can send it to me. Other than that, yeah, I will send you this link probably now if I find it before we finish, or we will circulate it on our site so that you can use it. But it's going to be really, really helpful, I am very sure.
Salu Sabi, you are the last one. Please go ahead and.
Okay. Same thing with me actually. I will just say one or two words of encouragement to our brothers, researchers, students, and fellow colleagues. Actually, you will be surprised if I'm to say I'm a mathematician, but I have done a few systematic review work and meta-analysis. In fact, Doctor is my very close friend. We have been discussing about this research and other things actually. So this kind of talk actually is very important, especially in our places where we are having lack of access to those informations. So, but to my surprise, actually, sometimes I used to feel ashamed for seeing the number of people joining this kind of program. It is really something that you cannot find anywhere. Sometimes because presentation is different, you can go to YouTube, find any similar presentation. But when it is done in this way, you can have the chance to ask direct question to the presenter. he can be able to explain and make so many effort to clarify a lot of things for you to understand that you cannot find anywhere. So please, I don't know, but please, those of you that are here, try to be joining this kind of program. We have similar in Ario mentorship program. I don't know if any of you knows about that, but it's really, really, really important. Thank you so much, Doctor, for this wonderful presentation. I too myself, I really learn a lot. Thank you so much. Thank you so much. Yeah, we keep in touch. Thank you, Buhari, for giving me the chance to talk. Thank you so much.
Thank you very much for your comment.
Thank you so much, Salihu. Yeah, definitely one of the very successful people, I will say Salihu, for those of you who don't know him. Yeah, I just don't think I have time to say a lot, but definitely if you are from that angle, Salihu is a very resourceful person, and you can get to Salihu. Is one of the best that we can find, especially in the field of mathematics with intersection to health. So just wanting to add, I just put the link to the article that I showed you earlier, the one we did on depression. So in case you want to recall how we work out some of the things, it's a very detailed article. And from that article, you can actually see the steps on how to conduct a systematic review, because we explain in very detail. We were targeting some sort of journal. That was the reason. So, and there are key things about the meta-analysis as well. So you can do that. And then thank you also, Zainab. Yeah, it's University of Melbourne. So definitely, I'm glad you're already here doing your PhD. Of course, you can get in touch if there is anything. We can, of course, work things together, because we live in a similar area. And
sorry, Doctor. Zainab is the one I told you about.
Okay. Oh, that's good. That's really good, because getting a scholarship in that university is something massive. One of the top 50 universities in the world. So congratulations, Zainab. I heard about you, and it's great for you to make it into that university with scholarship.
Please, please, Buhari, I don't know the means you can devise to encourage our people to be joining this program. It is very, very useful. Last week, as I was in the Washington State University, I delivered a seminar there in the Department of Mathematics. I was surprised. There was more than 80 participants. Among them was professors, doctors. So, but I don't know when it comes to our places, you have resourceful people like Doctor who can provide us with all the information, but you see people are coming, living, I don't know. So thank you so much.
Thank you very much, Salu. So, Doctor, is there anything that you can add?
That is it for now. If there is anything, people should get in touch to us via the social media.
Once again, thank you very much, Doctor, and thanks to everyone who happens to have a time and join us for this webinar, and thanks to all the people that asked questions, and special thanks to Dr. Salu for your special input, and then maybe we can really get in touch to see how we can come together also, so that you can contribute in Gamji Educational and Mentorship Forum as well. So like you see, the video is being recorded, and inshallah is going to be available in our YouTube page, Gamji Educational and Mentorship Forum. And for the rest of you that we couldn't be able to entertain your question, you can direct it to our email address, gamji@edu.com. Inshallah, Doctor will have time to respond to each of your questions. And keep in touch with all our social media handles, gamji@edu.com, at Facebook, Twitter, and Instagram. Event or programs like this one, we always organize, and inshallah you will be in touch with our program. So thank you very much, everyone.